So we're going to look at the case where we have a product of sine and cosine, but they have different arguments. What we're going to use is one of our trig identities. In this case, sine of alpha cosine of beta equals 1/2 sine alpha minus beta plus sine alpha plus beta. Once we do that identity, you'll see exactly where to go from there. So having this sheet of identities or knowing some of these identities can be really helpful in some of these integrals. So basically, this 13x is our alpha, and the 5x, is their beta. So the new integral is going to be 1/2 sine of 13x minus 5x plus, these both get multiplied by the half, so be careful of that, sine of 13x plus 5x dx. I'm going to go ahead and pull out the 1/2 in front of my integral, and I get sine of 8x plus sine of 18x dx. I'm going to do this antiderivative piece by piece. I've got the 1/2 out front. This is not a bad antiderivative. The antiderivative of sine is cosine of 8x, negative cosine of 8x. Now think about it, if we were taking the derivative of this, we'd have a chain rule, we'd have to multiply by 8. So I'm reversing the chain rule, so I got to divide by 8. You could also do this with a u substitution if you're not quite sure where this 8's coming from. This will be plus, and then the antiderivative of sine again is negative cosine. Leave the inside alone, and this time we got to divide by 18 plus c. Now we can distribute the 1/2 and simplify our positives and negatives, but we have our general antiderivative there.